Good evening, students. Welcome back to Rewadi Online Education Point. Rewadi Online Education Point. Today we will discuss class 6th physics, and this physics of class 9th physics, in which we will discuss the laws of motion. Laws of motion. We all know there are three laws of motion by the Newton law of motion. By the Newton, first law of motion, second law of motion, and the third law of motion. First law of motion, the law of inertia. It is called as law of inertia. Why? Because according to this law, every body is in motion or at rest. According to the first law of motion, everybody is in motion, will continue in motion, and everybody which is at rest is continuous at rest until an external force F is applied on it. External force F is applied on it. Let us consider a body A. It remains at rest. If it is at rest, remains at rest. वो रेस्ट में ही रहना चाहती है until a force is applied, external force, bahari force, applied on it. Right? Similarly, if the body B is in motion, if body B, let us consider body B in motion in this direction, that is having velocity V, right, will remains in motion until an external force is applied on it in this direction. If motion is in this direction, we have applied to external force in this direction so as to stop this. Right? So this is the first law of motion. This is the law of inertia. So we can say also define the inertia in this law. What is inertia now? Inertia is a property of the body. You can see here. It is the property of the body by which a body wants to move in motion. If a body is in motion, wants to move, always wants to move in motion. And if body is rest, वो चाहती है कि it wants to remain at rest. मतलब what it means, body in motion, जो motion में है वो क्या चाहती है, वो continue motion में रहना चाहती है. Right? It's a property of the body. Right? Similarly, what happens? Body is at rest. Body is at rest. वो रेस्ट पे रहना चाहती है भाई. Right? So this is the property. You can see the different examples of the inertia. For example, if we are traveling in a bus, we can see when the driver applies the brake, what happens? Our body, upper body, you can say upper body moves forward, because we all know the lower portion of our body will goes in motion when we are traveling when the bus is moving, right? So when our lower portion is in motion, then the driver applies the brake. What happens? Our body don't wants to stop because of the property of the inertia. It's not part to stop. It wants to continue in motion, but suddenly we have to apply the brakes to stop the bus, right? So what happens? This is the property of this is the property of our body by which we have to become at rest. Rest में रहना चाहते हैं तो rest में रहेंगे, or in case we are in motion, we want to always in motion, right? This is the property. Now, this is the very simple law, first law of motion, very simple law, right? What about second law? It is totally different from the first law, right? First law is the law of inertia. Similarly, I can say the second law of motion will define the linear momentum. What is linear momentum? Basically, linear momentum is the product of mass of the body and the velocity of the body, where m is the mass and v is the velocity of the body, right? So what's the statement, my dear? It's the statement of the second law of motion is, according to this law, the force on a body, we can define the force in the second law. Second law, it will define the force on a body. What is that? The force on a body is directly proportional to the, very important point, directly proportional to the rate of change of linear momentum. What is the rate, my dear? Rate is always the ratio with respect to time, derivative with respect to time, you can say. Okay, so what is the statement? Force is directly proportional to rate of change of linear momentum. What is the rate of change of linear momentum? What I can say, dt by dt of p. Now, change in momentum. What is the change in momentum? Initial, final momentum minus initial momentum. What is change? Change, you can say, always change, you can say delta p. What is that? Delta p is what? P2 minus p1, where p1 is the initial final momentum. Oh, sorry, p2 is the final momentum and p1 is the initial momentum of the body, for any body, you can say. Now, further, what we have? We have to consider F is equal to, we have to equate this. F is equal to, that is K dp by dt, right? Where K is the constant. Now, this K is find out by experimental values. Its value comes out to be 1, right? So, further, we can say the final equation from this, we can also write here F is equal to dp by dt, right? Simple. Now, by putting the values of this p, what is p? Linear momentum. We have to put the value of mass and a velocity. It's a product of mass and velocity. What that? Now we have, if we consider, right? We all know that almost in our studies we have consider our mass will be constant. Our mass will be constant, right? If mass is constant, now what we have to, if we have to find out the derivative of two terms, what do we have to do? We have to put the constant outside, right? We put the mass outside, then what we have? dv by dt. So this is the equation we have. Further, we all know, guys, what is dv by dt? Derivative of velocity, right? Derivative of displacement is called velocity. That is dx by dt. I can write also here dx by dt should be equal to v. Now, what is the derivative of velocity? It comes out to be acceleration, right? Now, the further we can generalize the equation force like this. Mass is constant and this dv by dt became a acceleration. So, from this we can derive from the second law of motion that force is the product of mass of the body and the acceleration attained by the body, right? So, this is the generalized form of the second law. Further, we will discuss in second law. After that second law, we have to discuss the third law of motion, right?